we use the same properties when simplifying variables in our roots. So if we look at 12x, we want to separate out any perfect squares. So this would be the square root of 4 is a perfect square, leaving us with the square root of 3x. The square root of 4 becomes 2, leaving us with 2, square root of 3x. And 3x doesn't have any perfect squares in it, so we're done. If we now examine the square root of 12x squared, we can see that this time there's a square root of 4 from the 12, but there's also a perfect square in x squared. So we would also take the square root of x squared, and then taking the leftover would give us square root of 3. Well, the square root of 4 is 2. The square root of x squared is x, and we're left with this square root of 3. So for higher powers of x, we now have to consider the squares and the leftover piece. So for 12x cubed, we have the 4 as a square in the 12, and then we have an x squared as part of our x cubed. So we would get the square root of 4, the square root of x squared, and now put the leftovers in a square root, which in this case would be 3x. So the square root of 4 becomes 2, square root of x squared becomes x, and then we're left with this leftover square root of 3x. Down here for 12x to the 4th, we do the same process. When we break up the 12, we're going to get square root of 4, and we're going to have a square root of 3 as part of our leftover. But notice that x to the 4th is itself a perfect square, leaving us then with just 3. So when we take the square roots, we're going to get 2 from the square root of 4. The square root of x to the 4th is x squared, and then we're left with our square root of 3.